And you'll see that the problem that we just did, that was question number 1. Now you might need a separate sheet of paper because there's so much work to do on these problems. Let's try number 2 right now. So what is step 1?
Multiply
A times C. Ladies and gentlemen, when we do that, what do we get? We get 6. And how about step 2? What's step 2? You think of the multiples of that answer, which is 6, that combines together to give you 5. How about we make a list? Let's make a list. We have 1 times 6, that's the way to get 6, or 2 times 3, and that's about it. Which pair of numbers gives us 5? 2 and 3. So this is the right combo, the 2 and the 3. That's our answer for step 2. Moving on to step 3. What is step 3? Step 3 is to replace your b value 5n and make it as 2 separate terms with the pair of numbers you just found from step 2. So let me rewrite it. There's the first term, 3n squared. There it is. Let me take this 5n and rewrite it as 2n plus 3n. Okay, so that's a positive 2n plus 3n. Why? Because 2n plus 3n is really the 5n that you have up here. And last but not least, the plus 2 at the very end. Now, I don't know if you noticed, but check it out. I purposely left a little bit of space right here so I could already jump straight into factoring by grouping. So here's my first group. What could I pull out of there? I could pull out the greatest common factor, which is what? What could I pull out of the first group? What's in common in both terms in the first group? N. If I pull out an n, what would be left? 3n plus 2. How about the second group over here? What could I pull out from the 3n and the 2? Nothing. So this is a very special problem. We need to be able to do this. It's actually so easy that some people get confused. In order to factor by grouping, we want to pull out something. We want to forcefully pull out something, even if there's nothing. So check this out. I'm going to forcefully pull out a positive 1. I know it sounds ridiculous, because if you pull out a positive 1, what's going to be left? It's still going to be 3n plus 2. So I pull out a 1 and nothing changes. So you're probably thinking, why would I do that? Well, the whole purpose is so you could take a step back and realize, hey, I have a binomial, 3n plus 2 in my first group, and in my second group, I want to take that 3n plus 2 and pull it out of both at the same time. So let me do that here. I want to take this 3n plus 2 and this 3n plus 2 and pull them out of both groups at the same time and write it out here in front. So when we pull out the 3n plus 2's out to the front, what do we have left? We have an n, and then we have a plus 1. I just leave the exaggerated parentheses with this blank spot so you could see that they're actually missing. They're not there no more. Of course, I don't want you to write it like this on your answer sheet. I want you to write it with the correct size parentheses. 3n plus 2 times n plus 1. Of course, if you wanted to double check and make sure you have the right factored form, you could always distribute 3n times n is 3n squared, 3n times 1 is 3n, 2 times n is 2n, 2 times 1 is 2, and when you combine like terms, you should end up with the original quadratic trinomial. Okay, so let's move on. Let's try another one. Anybody want to pick one? 16. Wow, you're jumping to equations already, huh? How about one more expression before we...
14.
14? Sure, why not? 14. Okay, so 14, and then we'll move on to equations after we practice a little more of this multi-step process. So step 1 is to multiply a times c. By the way, you're always supposed to try to pull out a GCF first. So we have a 10, a 19, a 15. You can't pull out anything, so you always try to pull out the GCF first and then continue trying to factor. So we can't pull out the GCF. Let's try to do our multi-step process. Step 1 is a times c. A times c. That's going to be what? What's a times c? Negative 150. That's right. So we need to think of the multiples of negative 150 that combine together to give us the middle value, which happens to be negative 19. So for step 2, you might want to make a list of numbers of how to get negative 150. We have negative 1 times 150. If I combine that together, it gives me 149. So that's definitely not the b value of negative 19. And you could continue making a list one number at a time, like negative 2 times 75, right? Or negative 3 times, what is that, 50? Okay, and of course you could use a calculator. If we continue, okay, so I got the rest of these numbers with the calculator. I did 150 divided by 4, it didn't work. 150 divided by 5, that was 30. 150 divided by 6, that was 25. And that's how I came up with the multiples. So you could clearly see that this is the pair of numbers that we want. However, if I do add negative 6 and positive 25, that gives me positive 19, and this is a negative 19. So I need to actually change that to a negative 19 by making these values change signs. So I have the right numbers, I have the wrong signs. Let me change that to a plus, change that to a minus. Those are the two pair of numbers that I want for step 3. Now step 3 itself is to rewrite your whole trinomial but make it as a polynomial. Change your 3 terms to 4 terms. How? By taking these pair of numbers and rewriting your middle value as those two pair of numbers. So let's do that. We're going to have a 10w squared plus 6w minus 25w. And of course at the very end the minus 15. Okay, so again we changed a trinomial, the original was 3 terms, into 4 terms. Now why do we want 4 terms? So we could actually do factoring by grouping. So let's split this into 2 groups. I forgot to leave space in between there. Let me make some space. There it is. And now let me look at my first term, and what could I pull out of the first group? Not first term. What could I pull out of the first group? You pull out a 2 and a w. If I do pull out a 2 and a w, what would be left in there? 5w plus 3. Okay. And what could I pull out of the second group? Over here, the second group. What could I pull out of there? Negative 5. And if I do pull out a negative 5, what would be left inside? 5w plus 3. Luckily, it's the same exact binomial. So the 5w plus 3 that's in the first group and the 5w that's plus 3 is in the second group, I'm going to pull out and write it right in the front. Since I don't have that much space, I'm going to write it down here. 5w plus 3. Now, what's going to be left on the inside of the parentheses if I do pull out the binomials, pull it out here in front, the 2w is going to come down and the minus 5 is going to come down. So you have 2w minus 5. Ladies and gentlemen, we have factored. All right. Of course, you want to write them with the same size parenthesis. And there it is, 5w plus 3 times 2w minus 5. That is your answer for number 14. I did give you a page with all the answers so you could check your answers, but then again, even if you didn't have it, you could distribute and see if it gives you it originally. So let's move on to solving equations, like number 18. Shall we try number 18? So number 18, it is an equation, so what we're going to do, we recognize that this equation is equal to 0, so it would be nice if we could have or apply the zero product property. Something times something equals 0, you could split them and set them each equal to 0. Problem is we need to factor it first. So because the a value is 1, we have to go through the multi-step process. A times c. What is a times c? 40. Right? This is a, this is c. 5 times 8 is 40. Step 2. Think of the multiples of 40. 1 times 40. 2 times 20. 3 times, 4 times 10. 5 times 8. And that's it, right? So we have all these possibilities. Now, which pair of numbers combines together to give us the middle value, which is negative 22? 2 and 20. However, 2 and 20, if I combine it, gives me a positive 22. And we know that we need it to be a negative 22. So we have the right numbers. We just have the wrong signs. So we put a minus there and a plus right there, changing this. Wait a minute, sorry. Both minus, yeah. Minus and a minus, because they were both positive originally, we're changing both to negatives. So now we're able to do step 3, and step 3 is rewriting the quadratic trinomial equation, but as a polynomial. We're going to replace the negative 22d with a negative 2d and a negative 20d. There it is. All I've done is replace the negative 22d with the negative 2d and negative 20d. Notice I left some space between it. That way I could jump straight to factoring. What could I pull out of the first group? A d. All right. Now what would I have left if I pull out a d? 5d minus 2. Excellent. The second group. What could I pull out of the second group? A 4. But it would be better to pull out a negative 4. That way you will end up with the same binomial 5d minus 2. The next step would be to factor out what's in the first group and the second group, which is obviously the binomial 5d minus 2. So let's move out that 5d minus 2. So when we move the 5d minus 2 out, what's going to be left? The d and the minus 4. D minus 4. So of course there's your answer. You just want to write it in the correct sized format. Now that's our answer. Let's say you did want to double check it. Let's say you had some time left over in class. What you could do is distribute, right? 5d. So this is your answer. But if you distribute 5d times d, that'll be 5d squared. 5d squared. If you distribute 5d times negative 4, that'll be negative 20d. And if you distribute negative 2 times d, that'll be negative 2d. And last but not least, negative 2 times negative 4, that's going to be a positive 8. So if I combine the two middle terms, I will get negative 22d plus 8 at the very end and a 5d squared out in front. Now, if you do look at the original quadratic trinomial that we factored, 5d squared minus 22d plus 8, there it is, it's factored. Now keep in mind, actually I kind of messed up, I'll tell you why. I thought this was a regular expression that we were factoring, but the truth is it has an equals 0, which means that that equals 0 right there is going to come down right here, and you're going to have an equals 0 on the factored form, the binomial times the binomial. So the binomial times the binomial really does equal 0, which means that you could use the zero product property to split them and solve. So let me split them over here. I'm going to have 5d minus 2 equals 0, and the other one is going to be d minus 4 equals 0. And of course, if we add 2 here, add 2 over there, you're going to get 5d equals 2. Final step would be to divide by 5, divide by 5. So one answer is d equals 2/5, 2 divided by 5. The other one's going to be a simple answer, d equals 4. So of course we have two answers for this quadratic trinomial equation. The key is to look at your quadratic trinomial. Always try to pull out a GCF first. It's not going to work. So you're going to have to, because your a value is 1, you can't use the shortcut. Because your a value is not 1, it's 5, you can't use your shortcut. So you're going to have to do the long process. Step 1, a times c. Step 2, make a list of the multiples of that answer that combine together to give you middle value. Step 3 is to rewrite your middle value as those pair of numbers, the negative 2 and the negative 20. There it is, negative 2d and negative 20. And then you factor by grouping. You end up in factored form. Because it's an equation equal to 0, you have it equal to 0, which means this one equals 0. That's what it says up here. And this one could equal 0. That's what it says down here. When you solve both, you get those two answers, 2/5 and positive 4.